Okay, so I was able to figure out how to use interrupts on the STM8. The microcontroller that I'm using is the STM8S003K3, and I can show you my code. So I have the basic includes, which come as the default when you load in a program in ST Visual Develop. And here's the main code. So first off, I have a segment byte at 100 in RAM 1. This is the LED state, and then it goes into segment ROM, and this code here just clears all of the memory, makes it all zeros so it's nice and clean. And then you come down here to the initialized state. The initialized state runs only once. It initializes the LED pin as an output. It disables the interrupts, and then it goes into setting timer 2, the prescaler, the high and low bit, and then it goes on to enable the update interrupt, and finally it re-enables the interrupts. I go on to start timer 2 and set the LED to be low, and then I set the LED state to be high. So what that does is the LED state is just going to toggle down in the main loop, and I read the LED state to turn on and off the LED. So then we go into this loop function, and the loop pretty much just grabs the LED state from the memory, loads it into the accumulator, and then it moves the LED state into the PD ODR, which is the LED register. And then it just continues to do that over and over again. And then when timer 2 overflows, it comes down here to this segment vect it, which is the vector interrupt table, and the timer 2 overflow is 13, which when you put this into this code here, it will, when timer 2 overflows, the program will know where to go to for this overflow. And all of these other interrupts are just non-handled interrupts. So if any of these interrupts happen, it just goes into this piece of code, which pretty much just returns back to, it doesn't do anything, it just returns back to the code. So when we get an overflow from timer 2, we reset the interrupts, which is important because if you don't do that, then you're just going to continually be in your interrupt. So we reset that to zeros. We XOR the accumulator with FF, which is just going to toggle the state of the accumulator, which in turn toggles the LED state. And then we load the accumulator value into LED state, and then we return back to wherever we left off. And when we return back to, we may enter the interrupt on this line, or this line, or this line, and we're just going to return back to wherever we left off. And the next loop we go through, we load the LED state into the accumulator so that it's into the accumulator when we go into the overflow, and then we move LED state into the PD ODR for the LED, so that will toggle the LED. And we just go through this process until you stop the code. And I will show you the code running, and we'll be able to see timer 2 counting up and the LED turning on and off. So this is the STM
STM8S003K3 board. This is the dev board that I have, and you can see that the LED light is blinking. So whenever that interrupt, whenever timer 2 overflows, we toggle that LED light. And right now it's toggling at about 2 hertz, so 2 times a second. And it's a 50% duty cycle just because I'm toggling it on the same amount of time that I'm toggling it off. So let me show you the code, and we can see timer 2, the interrupt overflowing, and the registers toggling.
Alright, so here we are in the debug mode. You can see the code here on the left, and you can see the peripheral registers here in the middle. And we can go to timer 2's register. You can see all of the registers are initially set to their default values, which most of them are just 0. And you can see here over to the right side, this is the memory. So right now, if you look right here, this is FE. This is the location in memory for this LED state. So right now it is FE, which means that it is all ones except that very last bit. And you can actually, if I go in here, I can change the format to be, let's see, base binary. So you can see that this last bit is 0. When this bit controls the LED light, so when it's 0, the LED light is on. When it is 1, then it is off. So I'll leave it in this state to kind of show it toggling. If I come up here to hit run, you will see that this toggles back. Just this first bit is toggling between 0 and 1. The rest are also toggling, but they're not connected to anything at the time. So you can see, I'll pause it, and we can see that the timer 2 register has been filled with some information. You can see that this counters at 7D74. So when this value, now it's going to be counting up. So when it reaches this C350, that's when it overflows. So I can come in here and type in C3 4A, and that will change that register on the fly, and then I can toggle through the rest of the code. And if you look here, this is where we are in the code, so we're going to be moving the LED state into the LED register. So right now I see that the LED light is on, and we continue through this loop here, and we can see that here in this register we're counting up. We're at C343, C34D, E, F, and we get to C350. So right now it hasn't overflowed yet. We need to go another one, and then now it is overflowed. You can see that up here this timer 2 status register is now saying F, which has some other information in it, but basically says that the timer 2 has overflowed, and that triggers the interrupt to occur. And you can see here in the code that we end up going to timer 2 overflow. We end up resetting the interrupt, so we end up resetting this register here, or sorry, this register here. That one goes to all zeros. We XOR what is in the accumulator with FF, and that toggles all of the bits. We then load that into the LED state, which up here you can see that this will toggle to 1. So right now the LED state is high in this position, but the LED light has not turned off yet, because we need to move that LED state into the LED register, which we do here, and it turns it off. And then we continue through this loop until we overflow again, and it happens again. So that's how the code works. Thanks for watching. Bye.